Welcome to our channel Quaint. Today's topic of discussion is non-Abelian statistics, and this non-Abelian statistics will be discussed here in this video for the purpose of the discussion of quantum computing systems, next generation quantum computing systems. Okay, you know that in the field of quantum computing, qubits are used. In case of classical computers, bits are used. In case of quantum computers, qubits are used. Okay, but here in case of, I have already posted one video regarding, the topic was Majorana particles. Majorana particles, yes, using these particles, qubits are formed, but these are special types of qubits. Special types of qubits because they follow another statistics. Normally, the particles found in nature are of two types. One is bosonic particles, another one is fermionic particles. Bosonic particles follow Bose-Einstein statistics, and fermionic particles follow Fermi-Dirac statistics. But Majorana particles, these are special kind of particles. These particles do not follow either of the two, that is Bose-Einstein or Fermi-Dirac. Instead, these Majorana particles follow non-Abelian statistics. This is a different type of statistics and applicable only for this kind of particles. What is the requirement to use Majorana particles for the formation of qubits in case of quantum computing systems? I have already mentioned in my previous videos. I have already posted a few videos regarding quantum computing systems. So there you would find that quantum computing systems are not error-free. They are more prone to errors. They are not fault-tolerant. Even if a local environmental disturbance can disturb the entire quantum system. That means the present day quantum computers are not error free, okay, are not error resistant. So our purpose, means scientists' purpose, is to make the next generation computers to that level so that local disturbances cannot disturb the entire quantum system, means the entire quantum computer. It is not possible to avoid local disturbances such as heat, such as electromagnetic radiation. So many types of local disturbances may be there in your area of quantum computing system. So avoiding all those things is not practical. So our purpose is to develop machines, means quantum machines, quantum computers to that level so that local disturbances or minor disturbances cannot disturb the entire quantum system. And for that purpose, Majorana particles are used. And I have already mentioned in this video that Majorana particles obey a different kind of statistics known as non-Abelian statistics. What is actually specialty in this statistics? Suppose there are two particles, particle A and particle B. Now you keep the particle A in the position of particle B and keep the particle B in the position of particle A. That means what you have done is known as swapping. Positions are exchanged for the particles A and B. Now if you swap back the particles, particle A was moved to this position, now you take it back to this position. And for the particle B you do the same operation. So what is the final result? Final result looks like the initial state. Initially, object A or the particle A was at this position and object B or the particle B was at this position, and the final result is the same. So you can say that there is actually no change. But in case of Majorana particles, if you do such swapping, then it will not return back to its initial state. The order in which the swapping is made it goes to the memory of Majorana particles. Majorana particles are able to memorize all these things. Means Majorana particles are able to remember the history of the swapping. If you consider a case of braiding, you know that females are having normally long hair and braiding is done. Okay, so if you braid hair in one direction and then if you reverse the braiding operation, then what will happen? It will return back to its original position. But in case of quantum particles, I am talking about actually Majorana particles, Majorana Fermions. If you do braiding operation in case of Majorana Fermions, then that is not the case. That is not so simple. Whatever operation is being done on Majorana particles, all those things are going to the memory of Majorana particles. And this is the advantage of Majorana particles. By using this special property of Majorana particles, fault-tolerant quantum computers can be invented at ease. But what is the requirement? A requirement is to carefully manipulate the Majorana particles. When you are braiding one particle around another particle, that thing should be done carefully. So careful manipulation is required, and for that purpose, advanced technology is required. If you are able to carefully manipulate, or if you are able to carefully move one particle around the other one, then in that case you would be able to develop next generation quantum computers. And our purpose, I have already mentioned that next generation quantum computer means you are going to develop qubits which will be fault tolerant. Means if local disturbances cannot be avoided, if local disturbances are there, so local disturbances can disturb your quantum system only locally. Not the entire quantum system would be disturbed that way, because it has a long memory. The particles have a long memory. Whatever is done on the particles, everything remains in its memory. That is the advantage. And that is the special property of Majorana particles. Bosonic particles and fermionic particles do not obey such statistics or the non-Abelian statistics. That means non-Abelian, for the particles obeying non-Abelian statistics, they are non-commutative in nature. Anyway, those things will be discussed in a separate video. In this video, discussion of all the aspects of Majorana particles is not possible for me. Okay. Anyway, so this was all about non-Abelian statistics or Majorana particles used for the purpose of next generation quantum computers. Okay, so this is the end of this video. Thank you for watching this video.